Okay, so at some point in your life, someone told you that there was no Santa Claus. And if they hadn't yet, hit mute just for a few minutes. Okay? Um, so there was no Santa Claus, and up until that point, you thought there was a Santa Claus, and you found out there wasn't. It's just your parents giving you stuff, and you know that either rocked your world or you were fine with it because you still got stuff, right? Well, up until this point, all of your answers for all of these was no solution. Well, the more appropriate answer there should have probably been no real solution, because I'm going to show you something here. The square root of a -1 is actually equal to something that we're going to call I, which stands for an imaginary number. Okay? Now, this is not a joke. This is something that we utilize to maintain basically a place, maintain the ability to work with this, even though we don't have something that we know that you can't multiply something by itself and have it be a negative. That is, except for the letter I, the variable I, which is basically, it represents the square root of a -1. So when we look at the square root of 25, we can actually break that up into two parts. Okay, part that we can work with and part that we have to use I for. So if I say square root of -25 is the same thing as saying the square root of 25 times a -1. Well, if I look at those individually, I can take care of that. What is the square root of 5? Well, that's 5. Okay. By the way, I've seen some of you take the square root of a number and leave the square root over the 5. Okay. When you take the square root of 25, you've performed that operation. The radical should be gone. So the square root of 25 is 5, but the square root of -1, we're going to use I as a variable. So your answer here is just going to be 5I. There's no radical left over. It's just a 5 and an I, because the square root of 25 is 5. The square root of -1, we can use I to represent that. If that's the case. The square root of 4 is 2. The fact that it's negative means we're using I to say, I know what the square root of 4 is, it's 2, and by the way, it was negative, so this I is an indicator that it was negative. Okay. We look at this. There are a couple of things going on here. It's a 48, which is not a perfect square. 49 would have been. But there are perfect squares that evenly go into 48. Okay? And so if we look at that, if we look closely at that, well, 4 may be the obvious choice. So I'm going to break it down in maybe a multi-step way. We know that 4 goes into it, and I know that the square root of 4, because we just did it, is 2. So 4 times what? Well, it's 4 times 12. And then, oh, by the way, there's still that -1 in there. So we'll deal with that in a second. Okay? So if I take the 4 out, the square root of 4 is 2. But look at that, and the square root of -1 is I. Now, if the square root of 12 were done, we'd be done. But tell me a little bit about the square root of 12. There is another perfect square that evenly goes in there. In fact, 4 goes into 12 as well. So if I re-break this down, and you don't have to do this in this many steps, if you are able to recognize how to do it in one, and I'll show you that too. The square root of 4 we already know is 2, so when that comes out, we have another 2 out in front. So technically it's 2 times I times 2 times the square root of 3. That's a little messy because these guys can be combined. The square root of 2 times the square root of 2 is 4. I'm sorry, 2 times 2 is 4. Your I is still there, and technically the last thing you should write is the I. I don't think we're going to get too ticky-tacky on that here. 4 times the square root of 3, the I should be the thing at the end. But let me just show you, since we're talking about it. There's a bigger number that goes into 48 that's a perfect square, and that's 16. So if I recognize that, and I said instead 16 times 3 times -1, well, the square root of 16 is 4, bada bing. Square root of 3 can't be done. We leave it there, and then the square root of 1 is the I. So if you can recognize the biggest perfect square that goes in there, it's a quicker and easier task. Okay, and we're right here. Biggest number, 36. Square root of 36 times 2 times -1. That is 6 times the square root of 2, I. Uh-oh, there's an I out in front. So, not a big deal. When we take the 12 out, it's a 12I, and the I that was already out there. What happens when you get I times I? Well, let's go back to here. if I square both sides of this equation, I squared is the square root of -1 squared. Well, guess what happens when you square anything with a radical? You're left with whatever's inside. This is the first time we're able to square something that actually turns into a -1. I squared is equal to a -1, magically so. So over here, when I have I times the square root of -144, the 12 comes out. But now I have an I squared. And what is I squared equal to again? It's equal to a -1, so the answer is actually -12. Right. The last thing here is if we got 32, 16 goes into 32. So I've got 16 times 2 times -1. I've got the I squared out in front. Remember what I squared is? It's equal to 1. So or a -1. So I've got a -1 times square root of 16 is 4. Square root of 2 is the square root of 2. And then the -1 means there's another I out in front. So this becomes a -4 times the square root of 2 times I.